Welcome to this lesson on graphing absolute value functions. So an absolute value is a function in the form f of x equals the absolute value of x. So remember, absolute value means the distance, and it's always going to be positive. So let's go ahead and graph the parent function of the absolute value. So I am going to be graphing the absolute value of -5 first, which would be 5. So again, you can think of it like this, the absolute value. So I'm substituting in -5. So the absolute value of -5 is 5. That's what I'm doing. The absolute value of -4 would be +4. The absolute value of -3 is 3, and so forth and so on. And then when you get to 0, the absolute value of 0 is 0. The absolute value of 1 is 1, 2, 3, 4, 5. It just always gives you the positive number back. And so let's graph that. So you can think of f of x as y. So I'm going to graph the point -5, 5. So left 5, up 5. And then I'm going to graph the point -4, 4, -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and 5, 5. And I'm going to connect the points, the coordinate points. And then let's answer the questions below about this graph. So what shape does the absolute value function form? It forms, you can see very clearly, a V shape. So absolute value functions always make a V shape on the graph. Which makes sense because it's never going to go negative. That's why it's kind of like bouncing off of the 0 and going back up, because it always gives you the positive. What is the domain and range? Well, the domain, so that's looking this way. Well, it goes forever this way in the left direction, forever in the right direction, so that would be all real numbers. And then the range is looking at the y axis, or vertical up and down. So there's nothing down here. It starts at 0 and then it keeps going up forever. So it would be greater than or equal to 0. Y is greater than or equal to 0. What is the axis of symmetry? So what divides this graph in half? That would be here, which is the y-axis, which is also x equals 0. What is the y-intercept? So where does it touch the y-axis at? Well, it touches right here at 0, 0. And then are there any zeros? So basically, what are the x-intercepts? Well, it touches the x-axis also at 0, 0. So yes, 0, 0. So that's the parent function. That's the basic y equals the absolute value of x. You can also have transformations for absolute value. So remember, the parent function is the simplest form of the function. For an absolute value function, the parent function is f of x equals the absolute value of x. A transformation of that graph would be moving or changing the parent function. So let's look at the different transformations. So for example, if you wanted to move that graph up, you would add a constant, which is just a number, to the outside of the absolute value expression. So for example, the absolute value of x plus 5 would move that graph up 5. So let me just show you what that looks like up here. So here's the normal parent function. If I added 5, then I'm going to move the graph up 5. So my vertex, my 0 would be up here. So it would kind of look like this. So it would move it up 5 units. All right, and then if I wanted to move it down, I would subtract. So this would move the graph down 3. If I want to move it right or left, then I would put that inside the absolute value expression. So if I wanted to move it right, I would subtract 2 inside the absolute value expression. And it's kind of opposite of what you would think. If you wanted to move right, you would subtract. If you want to move left, you would add. So plus 8 would move it left 8. If I want to make a vertical stretch, then I would multiply outside of the absolute value expression by a number greater than 1. So like 5 times the absolute value of x is going to make the graph kind of tall and skinny. And then a vertical shrink would be a number between 0 and 1 that's going to kind of make it short and fat. And then if I want to reflect it, so it's going to be upside down, then I would put a negative on the outside, or basically multiply it by -1. So let's look at these examples. So number 1, how is this graph, the parent function, going to move? Well, if I add 9 on the outside of the absolute value expression, that's going to move it up 9. The second one, this part is moving it up 2. And then this part, the -1 inside of the absolute value expression, would move it right 1. If you want to pause the video and try the next score by yourselves, you can do that now. All right, number 3, we have this negative, so that's going to flip it upside down or reflect over the x-axis. And then I also have this 1/4, that's going to make it skinny, so that's going to be called a vertical stretch. So that graph would kind of look like this. Oh, sorry, that's not a stretch, that would be a shrink, my bad. I was looking at the next one. So it would look like this, kind of flat. All right, the next one, this would be a vertical stretch, so making it tall and skinny. And then this -3 would move it down 3 units. Number 5, this would move it to the left 4. And then number 6, we have a reflection over the x-axis, so flip it upside down. And then move it down 1.